Now I'm allowed to welcome Alexandra Ebert from Mostly AI with a talk on synthetic data for privacy, AI fairness, and democratizing data access. Alexandra Ebert is an ethical AI, synthetic data, and privacy expert and serves as a Chief Trust Officer at Mostly AI. She is also an advocate for privacy protection and is deeply passionate about ethical AI and ensuring the fair and responsible use of machine learning algorithms. The stage is yours.
Thank you very much. Is this already on? Yes, now it's on. Welcome, everybody. It's a pleasure to be here in Berlin today, and I have the pleasure of talking about synthetic data. I just need this thing here because to answer the question, why am I talking about synthetic data, I wanted to put up a quote from the European Commission's Joint Research Center from a report they did this year about synthetic data. And in this report, they stated many really nice things about synthetic data. For example, that it will be the key enabler for artificial intelligence in Europe, for business and also policy applications. Out of curiosity, who here in this audience has already heard about AI-generated synthetic data? Could you briefly show me your hands? That's actually quite a lot, so really happy to see that. For those of you who haven't heard about synthetic data before, what is AI-generated synthetic data? And to explain that, I love to show some images from NVIDIA research, because it's just easier to understand the concept of AI-generated synthetic data when you look at images. But it is the same technology, regardless of whether you use it to create synthetic images or synthetic text, synthetic banking data, synthetic healthcare data. But back to these images. I would assume everybody here in this audience would agree with me that these are actually real human beings. No worries, you don't have to show your hands again. I just assume you would agree with me. But as you could have guessed, all of these pictures here on the slide are actually synthetic human faces. Images of people that have never existed before. How were they created? It was done, as mentioned, as part of a research project from NVIDIA, where they trained a machine learning algorithm on hundreds of thousands of human faces, up to the point where this algorithm understood how a human face looks like. That humans usually have two eyes, a nose that is somewhere positioned in the middle of the face, and mouths that come in these shapes and sizes. And then, once this training was completed, the algorithm was capable to generate new synthetic faces. Faces of people that have never existed before, but that nonetheless look super realistic. And it's not a simple process where you go like, okay, I take the eyes of person A in my training sample and the mouth of person B in my training sample, and I just shuffle this together and create a new human face. It's really a process where you start drawing these data points, these synthetic images from scratch. And this is the exact same procedure that you can do with structured behavioral data, like medical data or financial transaction data. We as a company provide a synthetic data generator, but there are also open source solutions, or some organizations are building their own synthetic generators. All of them work rather similarly. You provide your input data, the real financial transaction data, for example, and the synthetic data generator is capable of automatically learning all the patterns, the correlations, the time dependencies in this data. Basically, the algorithm is capable of understanding how your customers act and behave. And then, once this training is completed, in a completely separate step, this knowledge is used to create new synthetic customers. And in my example, the synthetic transactions of these customers. And if you compare the synthetic data with the real data from a statistical point of view, you will see that you get nearly the exact same results. It has the same utility as your real data. But from a privacy point of view, there's no one-to-one relation in there from your real data subjects and your synthetic data subjects. So, from a privacy point of view, you're out of scope of GDPR, out of scope of CCPA, and all the other modern privacy regulations there. Therefore, synthetic data helps you with privacy protection. But why else is it needed? And there are basically two reasons for that. One reason is today's data fuel crisis. Everybody in the audience will know that today utilizing and innovating with your data isn't that easy. We have GDPR, we have a whole spectrum of other acts and regulations that are coming in our direction, and also the ethical risk associated with data use in AI is something that holds organizations back to make use from the data assets. So even though we have lots of data, in reality, not much of the data gets used. As mentioned, regulations don't make it easy, neither in Europe nor around the globe. The second problem, why synthetic data is needed, is actually traditional anonymization techniques, like masking or obfuscation. Here the problem is that these techniques have worked nicely decades ago when it was used for small data sets, but they simply fail for big data sets. Here I think everybody can guess who the person on the left or right, whichever screen you're currently looking on is, and you can see that not enough data was deleted or masked to protect the privacy of the former president. If you delete more data, you also destroy the utility of your data sets, which is not beneficial if you want to, for example, train AI on that data. But even if you delete that much data, sorry, I need to get a glass of water. But even if you delete that much data, research has shown over and over again that it is still super easy to re-identify your customers. So with that type of technologies, you're simply not GDPR compliant and safe anymore. And these are basically the two reasons why you need synthetic data: to help you unlock your data assets and to help you to retain the utility in your data and to still make re-identification impossible. Here, in comparison, you can see that with synthetic data, you can retain nearly all of the information that's present in a data set. From a statistical point of view, it's highly representative. It's also highly realistic if you zoom down to the individual synthetic subjects. Yet, there's no data point in there, no real data that can lead to re-identification of this data. What does this help organizations to achieve? Firstly, eliminating privacy risks. Secondly, being significantly faster in data innovation and AI projects. So what we hear from our enterprise clients, when they want to access data, it oftentimes takes a few weeks, more commonly 3 months, 6 months, or 8 months if they want to externally share data. With synthetic data, they can reduce this time to data to a few hours or 1 day if it's a large data set or a database. Plus, they're much more accurate. If you remember the graph that I just showed, you don't get 100%, but you get nearly all of the information that you can retain with synthetic data. This helps you to collaborate more on data, also to automate anonymization and save costs by doing this. And it helps you to improve your customer understanding and to improve your AI models because you can work on more granular, more diverse and richer data assets. There are also some limitations to synthetic data. One thing is that it doesn't protect business secrets. So it retains all the statistics in a data set while protecting personal secrets, privacy-sensitive information. This is something you have to keep in mind if you, for example, want to openly share the data and don't want to reveal to your competitor who your most profitable customer segment is, for example. It's also not suitable for scenarios where you want to get back to real individuals at one point in time. Synthetic data can't be reverse engineered. You can't get back to the real data. And lastly, it's also not suitable for small data use cases. It's a big data technology. What are the use cases? So certainly the top use case is AI training and advanced analytics. The second most common use case for synthetic data today is third-party data sharing and collaboration. Also, software testing is something that's quite frequently used. Other than that, open data, AI bias detection, and quite a lot about responsible AI and AI governance. The industries who are currently the pioneers in synthetic data use are banks, insurances, telecommunication providers, and also public sector organizations. Today, I wanted to talk about open data and democratizing data access particularly. We've heard it in a few panels before. Without data, we will never be an innovator in the European Union. We will not be able to adopt AI at scale if we don't have data available. And this is something where synthetic data can help. To give you a few examples, by the way, I'm not seeing a timer, so I have no clue if I'm already talking for 30 minutes. I hope I'm not. One example is the health insurance Humana from the United States. They have last year in December published an openly available healthcare dataset of 1.5 million synthetic subjects to facilitate research, to facilitate collaboration. A dataset with that granularity is something that you don't often come across with. With synthetic data, it is possible without infringing privacy. The city of Vienna is also on the journey of publishing synthetic citizen data to facilitate research and to also give access to data for the startups and SMEs that we have in Austria. There's also a project, a tender that we at Mostly AI won from INGEF that is sponsored by the German Ministry of Health, where it's also the idea to modernize healthcare in Germany and to make sure that data can be utilized while privacy is protected. And another thing that I wanted to share with you today is the report that I already mentioned in the beginning when I had the quote on the screen from the Joint Research Center of the European Commission. For just 1 second, please imagine what would be possible if researchers in Europe had access to a synthetic version of all the cancer data patients, all the medical cancer data that we have available in the European Union, but that currently is rarely used. The Joint Research Center wanted to support that mission and looked into synthetic data for the past 2 years. And they wrote a report that was published a few months ago. It's 80 pages long, so if you're really into synthetic data, I can recommend reading it. If not, I'm publishing a blog post soon, which has some of the highlights in there. But what they found is that synthetic data really is this technology that can help us to retain the insights that we have in data while protecting the sensitive private information of data subjects. And that they see this as one of the big opportunities for the European Union to achieve their goals, to become a global leader in artificial intelligence, and also to become a data-driven collection of nations where organizations are more digitally transformed and in a better position to use data. So really highly recommended read. Lastly, I also want to talk about synthetic data in the context of responsible AI and fairness. We all know the AI Act is on its way, where, The AI Act is on its way, where the European Union is trying to create regulation that makes sure that the European Union not only becomes a global player in artificial intelligence, but does it the European way, to build trustworthy systems, human-centered systems, responsible systems that we all can rely on. So if we talk about responsible AI, there are actually different pillars or different requirements what a responsible system has to fulfill. There's fairness and inclusion. There's transparency and explainability, robustness, reliability, safety, security, and also that privacy is adhered to, or privacy laws are adhered to. Many, many things that go into developing an AI system that's actually responsible. And synthetic data can help with many of those pillars. Privacy, I already talked at length about, but it also is capable to help organizations to develop AI that's fairer, better explainable, or that externals can audit. Briefly talking about the AI assurance ecosystem and AI audits. I think everybody here will know that we have a global talent shortage on AI talent. But we actually have an even bigger shortage of responsible AI talent. And that's a problem, because if you want to have even more organizations and institutions that use, develop, and deploy artificial intelligence, and those people are not skilled to make responsible AI happen, then it's quite likely that we're not going to reach our goal of having responsible, ethical, trustworthy AI. And to counteract this development, the European Union, or also the UK government, are working on something that's oftentimes termed AI assurance ecosystem. So basically an ecosystem where organizations can turn to and can get tools, service providers, consultants, external auditors or certification bodies that help them to make sure that the AI they build or deploy is actually fair or explainable, for example. And all of these activities, or many of these activities, require that data can be shared. because it's impossible to just look at the code of a model and give a stamp on it and tell somebody this is fair or this is not fair. You need granular, realistic, representative, or sometimes even over-representatives data, for example, data that has plenty of examples of minorities, to really stress test an algorithm and figure out whether it's discriminating against minorities or not. Of course, granular data always raises privacy flags, and therefore synthetic data can help organizations to audit AI systems and assess whether there's bias present or not without infringing privacy. Similarly, synthetic data can help with explainability. Due to time, I will not go into detail about that, but we've worked on an interesting project together with NVIDIA, and you can read more about this on this blog post. Now coming to fairness, I think everybody here will know that bias in AI and discrimination is a problem. If you look into the news regularly, there are some big reports about algorithms discriminating against females, against people of color, or being racistic or something like that. So it is something that needs to be addressed, and it is something that's a priority topic for many boards around the world in large organizations, and as we know, also for regulators. The problem is, in contrast to privacy, fairness is an even more difficult beast to tackle, because there's not the question, is it private or is it not private, but it's really hard to define what is actually fair and what is not fair. To give you an example, if I would ask my fictitious 5-year-old nephew and my fictitious 3-year-old niece who should get how many pieces of my 6 fictitious pieces of chocolate, then he would probably say, well, I should get 4, I'm the bigger one. And she would say, well, I did the dishes yesterday, I should get 4 and he should only get 2. So fairness is really a hard concept to define. Besides that, there are many, many reasons how bias can end up in an AI model, and it's really hard to address them. If you want to learn more about that, there's also a good blog post on the Mostly AI website that was also featured in Forbes and some other publications. But to give you an example how synthetic data can help with fairness, if you look into algorithms and the training data sets that are used, you oftentimes have this problem. The real world looks something like that. But the training set that is used or that is available, because oftentimes it's challenging to get enough training data for your AI models because of privacy, is not really representative of the real world. So if you train a model on this gold standard available data set, it will be great at recognizing people with blonde hair, but suck with recognizing the majority of the population that we have around the globe. And this is an issue, and it's really hard to get enough real world data to counteract that. With synthetic data, you can create more examples from certain groups to make sure that your data is balanced. Again, to illustrate, I'm lending from NVIDIA because it's just easier to see with images, but we do it, for example, with structured data. With synthetic data, you can create more data points, more examples that are more diverse, that are more representative of minorities, to build a data set that helps you to train models that don't discriminate against minorities. But this is, again, just one example how synthetic data helps with fairness. It can also help you with accessing sensitive attributes. This is actually one of the biggest challenges of fairness practitioners, that in the real world, they are oftentimes not allowed to collect data about gender or race. And this then in turn leads to them operating in the blind, not knowing whether the model exhibits bias or not. With synthetic data, it would be possible to access this data without infringing the privacy of the people. And then there are also a few other things how synthetic data can help. Again, due to time, I'm recommending a blog post on that. Or if you're interested in a real-world case, I also had 2 people from Humana on my blog, on my podcast, who talked about how they used fair synthetic data to make sure that the resources that they allocate as a healthcare insurance is distributed fairly, also against minorities. So this is definitely something for everybody interested in AI fairness to check out. Since I'm approaching the end of my talk, I'm closing now, and I'm curious for your questions. If you have questions later on, you can also reach me via LinkedIn or via email, and I'm happy to answer them later on. Thank you very much.
Thank you very much. I fear we're a bit out of time, but in case there's a quick question, otherwise I would just say that I hope, as you said, you'll be around. So
Absolutely.
any more questions in depth. And I thank you very much, because oftentimes we hear GDPR is a hurdle, and
it doesn't have to be.
It doesn't have to be, as we have seen today. So thank you very much.
Thank you so very much for having me. Thank you.